In this video, we'll review mole calculations. And the last couple, the beginning of the study guide, it was kind of nice because every section had the same kind of calculation, so it was good to practice. You set them all up the same way. This next section here, these are all kind of jumbled. So we really have to look for what we have and what we want, and that'll help us set up our proportions. How many molecules are in 22.5 moles of nitrogen trihydride? So I start with not only the number, but the unit of what I have. I have 22.5 moles of nitrogen trihydride, NH3. I know I'm going to set up some proportions. I want to cancel the unit that I have. And then I look for what they want. How many molecules? Molecules goes on top. Molecules. I have my proportions set, and now I can just fill in the units. There should be 6.02 times 10 to the 23rd molecules in 1 mole of anything. 1 mole of nitrogen trihydride, 1 mole of anything. Now I can see that moles cancel. I have everything set up right. I'm going to multiply across. Every 1 mole has 6.02 times 10 to the 23rd molecules. I got a lot of moles, 22.5. 1.35 times 10 to the 25th molecules of NH3. The original had 3 sig figs, so I left 3. Seems good? Done. So it's just a little bit different way of wording these from what we saw at the beginning of the study guide, but it's the same kind of calculations. What is the mass of 2.97 moles of oxygen? So I have 2.97 moles. The abbreviation for mole is MOL, drop the E. Moles of oxygen. I know I want to switch this out of moles. So at the beginning it says, what is the mass? Mass will always refer to grams. So I know when I see mass, I need my periodic table. Oxygen. This periodic table really says 16.00, and that is the molar mass, the mass of 1 mole. Moles and moles will cancel. I'm going to multiply across. 47.5 grams of oxygen. So again, don't try to memorize. If I'm going from this to this, you multiply. This to this, you divide. Set up the proportion. That's all you need to know. Then the proportion will tell you if you multiply, divide, what numbers to use. This is great, and it makes sense. Every 1 mole of oxygen weighs about 16 grams, and I have about 3 moles. 3 times 16, about 48. Sounds good to me. Done. Let's try a couple others, make sure we're catching on. Other ways they could word this. What is the mass of 1 mole of ammonium ions? Ooh, tricky. We haven't done an ion. Well, when they say here, the mass of 1 mole, that's molar mass. All we got to do is add this up on our periodic table. That'll give us the molar mass. I do need the formula. Ammonium ions. Ammonium ions, NH4 plus 1. Ooh, tricky. Yeah, we haven't done an ion yet. Okay, so you have a few options here. Plus 1. There we go. Option 1, you could set up a fancy calculation. We have 1 mole of ammonium plus 1. I know I want to do a unit conversion where I cancel moles, and when they say what is the mass, that means grams. So I know I can find the mass on a periodic table. I'm going to add 1 nitrogen plus 4 hydrogen. And that's it. You do not need to do anything differently because this has a charge. It's totally fine. The charge means that we gained or lost electrons. Well, electrons don't really have substantial mass, so this is totally fine. We'll just add the nitrogen and the 4 hydrogens for a mass of 18.05 grams for 1 mole. We lost an electron. Who cares? The mass is so small it really doesn't affect the overall molar mass of the particle. In hindsight, that's really all I needed to do. Molar mass added up on a periodic table. That is your answer. 18.05 grams per mole. Done. Oh, not so bad. We can do this with sulfate. I have 0.86 moles of sulfate. SO4 minus 2. You can totally look these up. You do not need to memorize all these polyatomics and their charges. I'm going to set up my proportion to cancel moles. What is the mass? Mass on the top. Oh, I can do this. I'll find the mass on my periodic table. It's the mass of 1 mole. I need sulfur plus 4 times oxygen. And that's it. The minus 2 charge means that I have 2 extra electrons. But again, the electron mass is so small that it doesn't change my overall molar mass. So if I add sulfur plus 4 oxygen, 96.07. And really, this was the same calculation as above. Moles canceling moles, moles canceling moles, switching them to grams. The only difference is that I don't have 1 full mole. I only have 0.86 moles. So I will need to multiply across. And if I just go 2 sig figs, how about 83 grams? 83 grams of sulfate. Up on top, I don't mind too if you just have that as grams. It's asking what is the mass. And that would be my ammonium ion. Plus 1. So it's okay if you have an ion. The molar mass does not change if we gain or lose a few electrons. Then let's look at these last 2 here. I have, let's see here, 1 atom of vanadium. What is the mass of 1 atom of vanadium? 1 atom of vanadium. I know I want a proportion. I'm going to cancel atoms. I want mass or grams. The mass I can find on my periodic table. Vanadium, 50.94 grams. Now that is not the mass of 1 atom. That is the mass of a mole of atoms. 6.02 times 10 to the 23rd atoms. We need to divide these. And I should get a crazy small number. Atoms and atoms will cancel just like I want. The mass per atom. Whoa. And again, maybe I'll go like 3 sig figs. I don't really want to just go 1. 8.46 times 10 to the negative 23rd. You can say grams per atom. Just grams would be fine. That's reasonable because this is for 1 atom. It's got to be crazy, crazy small. So be a little careful on how that's worded. In number 3, it was the mass of 1 mole. Well, that should be something that I could actually measure in the lab. That's a lot of particles. 1 atom, crazy small number I'm expecting. I cannot take the mass of one atom. Not in the lab. Alright, let's do one more. Number 6. What is the mass of 0.655 moles iron 3 oxide? Alright. What do I have? 0.655 moles of iron 3, so iron is plus 3, oxide minus 2. I need to make this neutral. Fe2O3 gives me a plus 6 minus 6. I want my proportion to cancel moles and switch it to grams. What mass? The periodic table will tell me the mass of 1 mole, but again, since this one is a compound, I did need the formula, and I will need the molar mass. So 2 times iron plus 3 times oxygen is about 159.69 grams. We're going to multiply across. Moles and moles cancel just like I want. And with 3 significant figures, how about 105 grams of Fe2O3, iron oxide? Almost. We're thinking about it. There it is, Fe2O3. And again, that makes some sense. So I got about 2/3 of a mole. I should have about 2/3 of the mass. So that number 105, that seems very reasonable. So with things that are maybe worded a little different or jumbled up a little bit, just watch what you have, what is the quantity and what are the units, and set up your proportions so that you cancel the unit you have and switch it to whatever you're wanting.